Hi, this is Professor Jim H. Chen at California State University, Long Beach. In this video lesson today, we'll learn all about lines. The most important feature for a line or a linear trend is that it has a slope, which is the rate of change. For example, if you want to figure out the slope of a line, we can pick any 2 points. Here's a line. Let's pick the point A, which has the coordinates x1, y1, point B, which has the coordinate x2 and y2. Then we define slope between those 2 points as the change in their y value over the change in their x values. That's denoted as change in y over change in x, and that is also known as the rise over run. That is typically denoted by the symbol m. In real life situations, we actually realize this as the rate of change. What do we really mean by rise over run, or the change in y over change in x? Well, to travel from point A to point B, we first have to travel horizontally by this much. Well, this much is the change in their x values. And then from that point on, I have to travel this much to get to point B. Well, that is the vertical rise, which is the change in the y value. So if you now take the change in their y value over the change in the x values, that is exactly the same as a rise over run. If you were to travel to the right, and that is a positive quantity, if you travel up, and that's also a positive quantity. With this notation, rise over run using the coordinates calculation would then be y2 minus y1 over x2 minus x1. But that's also the same as doing y1 minus y2 over x1 minus x2, because you can travel from point A to point B, or you can travel from point B to point A. You get exactly the same slope. Let's take an example. If we want to find a slope of a line passing through the point P, which is 2, 1, and the point Q, which has coordinates 8, 5, using the formula we've just described here, we would then do the change in their y value over the change in their x value. And again, you can do this in any order as long as you're consistent in both x and the y directions. I'm going to take the point Q minus the point P here. That gives me a 5 minus 1 over a minus 2, which is 4 over 6, and then reduces down to 2 over 3. And then use this quantity of 2/3 to tell you how to get from one point to the next. All you need to do is go up 2 units and then go over to the right 3 units to go from one to the next point. If you want to actually reach all the points on the line, you just keep doing the 2/3, the rise up 2, the over 3 behavior all the time. That way you get all of the points on the line. There are some useful facts about the lines. First, lines that extend from quadrant 3 to quadrant 1 would always have positive slope. This is because if you have a line that goes from quadrant 3 to quadrant 1 like this, then pick any 2 points on the line and you travel from point 1 to point 2, you always have to go up and then to the right. Well, going up corresponds to positive quantity, and going to the right also corresponds to positive quantity. So your slope, which is rise over run, would always produce a positive quantity. You can use different order pairs of points on the line. For example, if you want to go from this point A to this point B, you go down and over to the left. Well, going down corresponds to negative quantity, and going to the left also corresponds to negative quantity. But in this case, you also get negative over negative. That corresponds to a positive slope as well. On the other hand, lines that extend from quadrant 4 to quadrant 2 will always have negative slope. Here we have a line going from quadrant 4 to quadrant 2. If you pick any 2 points on this line, let's say point A and point B, in order to travel from point A to point B, we have to first go down, which corresponds to a negative quantity, and over to the right, which corresponds to a positive quantity. In either case, we would have a negative slope. When do you think a line has 0 slope? A line has a 0 slope when a rise over run is 0. Well, this equation is equal to 0 if and only if the rise portion is equal to 0, because a fraction can only be equal to 0 if the numerator is equal to 0. Well, if the rise portion is equal to 0, that means there is no vertical change. So the change in the y value is equal to 0. What kind of line would then have no vertical change? It's a horizontal line. From point A to point B on the horizontal line, the y value stays the same. So there is no change in the y value. There is a change in the x value though. Regardless of the change in the x values, there is no change in the y. This means all horizontal lines have slope 0. On the other hand, what kind of line would then have undefined slope? Well, it would be the case if rise over run is undefined. Well, this expression is undefined when the denominator is undefined. That means the run portion is 0. The run portion represents the change in the x value, so this means when then there is no change in the x value. Well, what kind of line would have no change in the x value? Vertical lines. Any point on the vertical line here would then have the same x value. There are two convenient ways to construct equation of the lines. One is called the slope-intercept form, and the other one is called the point-slope form. As the name suggests, these are the forms that are used when a certain information is known. For example, in the point-slope form, it's actually convenient to use this when we know a point on the line as well as the slope on the line. For the slope-intercept form, we use this form when we know the slope and the y-intercept of the line. Let's look at the point-slope form first. The equation for the point-slope form is y minus y1 equals m times x minus x1. So this means that as soon as you have the slope information and information about a point, that is x1, y1, then we can immediately plug into this form and try to reduce it down to, for example, if you have a point 1 comma negative 3 and a slope of negative 1/2, then the equation of the line using this form can be written as y minus negative 3 equals negative 1/2 times x minus 1. To reduce this equation down to its simplest form, well, first, let's leave y on the left-hand side by itself. That's negative 1/2 x on the right, and then distribute this negative 1/2 in, I get a positive 1/2. And then here, on the left-hand side, you actually have minus negative 3, which corresponds to positive 3. But when you move it to the right-hand side, that becomes a minus 3. So I can write this as y equals negative 1/2 x minus 5/2. I'm going to now sketch the graph based on this equation. You would then start with the point you actually know, which is 1, negative 3. So here's this 1. Let's say this is negative 3. You actually have this point right here. And the slope being negative 1/2 tells you that you can either treat it as negative 1 over 2, or you can treat it as 1 over negative 2. If you treat it as a negative 1 over 2, that means you're going to go down 1 unit and then over to the right 2 units to reach the second point. If you actually treat it as 1 over negative 2, meaning that you can rise up 1 unit first and then go to the left 2 units to reach the second point. You can see that either way you're going to reach points that will lie on the same line. The second form is called the slope-intercept form, which looks like a y equals mx plus b. The m is the slope and b is the y-intercept. It's pretty obvious that this form is convenient when the slope information and the y-intercept information is available. Or we can actually look at this a little bit differently. If the equation is not given to you in this form, you can actually turn it into this form. You could extract the y and the slope information easily once the equation is in this form. It really helps when you have to graph. For example, if I give you the equation 2x minus 3y minus 12 equal to 0. It's currently not in the slope-intercept form. Before I have to graph this equation, it would be easier if I can turn it into that form and extract the y-intercept and the slope information right away. At first, I identify my location of my y-intercept on the y-axis. Well, that's negative 4. So I'm going to first label negative 4, and I know for sure my line needs to go through this point here because that's the y-intercept. And the slope being 2/3, meaning that to get to the next point, I can either go up 2 units and run over to the right 3 units to reach the second point, or I can actually go the other way. I can go down 2 units and then right over to the left 3 units. So I can go down and then over to the left 3 units to reach this other point. If you actually connect all these points, you get the equation of the line. It would be nice to actually try to label your graph as carefully as possible because sometimes the variable's names change. In this case, the x-axis is the variable x, and it is the y variable on the vertical direction here. The point that this line goes through on the y-axis is -4. It's not readily available on the point where the line goes through the x-axis. You could actually calculate it, but you don't really have to. It'd be nice to know this is actually the origin. And each time we have a tick mark of 1 point. A couple more useful facts that you should know about. First, parallel lines have the same slope. Although they might have different y-intercepts because they're only parallel but not identical, but the rate of change, i.e. their steepness, is exactly the same. For example, if this line here has slope of 1 with the y-intercept 0, because it actually goes through the origin, then a line that is parallel to it, let's say this one here, would also have slope 1, but this time it's not intersecting at the origin anymore. It's actually intersecting the y-axis at maybe 1 there. And then if you have another line that is parallel to it, like say right here, it will also have the same slope, but intersecting at a different point, I'll say -1 there. On the other hand, perpendicular lines satisfy the relationship the product of their slopes is equal to -1. Another way to interpret this equation here is to, for example, solve for m2 in terms of m1. So you see that m2 is equal to -1 over m1, which means that as soon as you know the slope of one of them, you just invert it and add a negative sign in front to get to the second one. For example, if I have a line here, L1, with a slope of 2, then the line that is perpendicular to it, which is L2 in this picture, would then have the slope that is 1 over 2, because you invert it first, and then you just add a negative sign in front, which is -1/2. Next, let's try to model rate of change using a slope. A small business buys a computer for $4,000. After 4 years, the value of the computer is expected to be $200. Right away, you can tell that the price of the computer actually drops over time. So we can see that time is the variable that's changing, and the price or the value depends on the time. For accounting purposes, the business uses linear depreciation to assess the value of the computer at a given time. This means that if V is the value of the computer at time t, then the linear equation is used to relate V and t. The t variable here is the independent variable because that's what's changing. And the value of the computer depends on t, which makes it a dependent variable. So in terms of kind of a pictorial picture, forming that kind of a visualization of what this means, you wanted to draw the horizontal axis as the one that is independent variable, so in this case t, and you wanted to use the vertical axis as the dependent variable, which in this case is v. Now, when you're changing the variable names, you wanted to solve the problem based on the name of your variables. There's no longer an x variable, and there's no longer a y variable, so just be careful in terms of your wording. Well, the question wants you to find a linear equation that relates v and t and sketch the graph of this linear equation. We can actually do part A and part B simultaneously. If we lay down the coordinate system as t versus v, that means when we write our points, we should think of as a t comma v coordinate points. In order to actually get an equation of a line, we need at least 2 points, or some sort of information about this equation. We actually have 2 points given to us. If you read from the question, we know that in the beginning of the time, the computer is worth $4,000. So that is when t is equal to 0 and the value of the computer is at 4,000. That right away gives us the first point right here. We also know that after 4 years, the computer is expected to be only worth $200. So if you travel in time to 4 years, so at this point, we're at 4 years, the value of the computer should only be $200. So if this is the $200 mark on the value axis, then it should then go through this point. So this point here is 4, 200. The question says that the business used a linear depreciation process. Now the keyword here is linear, because I don't know what's going to happen in between year 0 and year 4, typically. Right? It could depreciate really fast, or it could depreciate really slow. But it says that we're going to assume it has a linear depreciation model, which means that it should be a straight line connecting those 2 points. If I were to tell you that this is going to be a quadratic depreciation model, that means there should be a quadratic curve connecting those 2 points. Now, if you want, you could extend this line a little bit longer, although you wouldn't want to go past year 0 because it doesn't really make sense to have negative year. Actually, it wouldn't make any sense to go beyond the t-axis. So if you were to keep going on this depreciation model, you would probably want to stop right there because that's when it reaches $0 for its value. And it doesn't make sense to go beyond that to have negative value. So we kind of answer part B first. Now let's look at part A. We want to find a linear equation that relates V and T. Well, we've come up with 2 points already, right? The first point is 0, 4,000, and the second point is 4, 200. We can actually find a slope between those 2 points, and once we have the slope and we have, we can use either one of those 2 points to come up with an equation using the point-slope form. The slope is going to be the change in the y value, which is 200 minus 4,000, over the change in the x value, which is 4 minus 0. Now, I've actually used the wrong terminology here. I can no longer speak of changing y over changing x. It's really changing v over changing t. Okay, so if you simplify this expression here, we get negative 3,800 divided by 4, which is negative 950. Now, what does this number mean? Well, the negative tells us it's depreciation. And the actual value of 950 says that it's the change in dollar amount per year, because that's what changing V over changing T mean. If you look at the unit on the V value, which is in dollars, and the unit on the T value, which is in year, this change in V over change in T is a rate, and the unit on that rate is dollars per year. So the way we interpret this negative 950 is, in this context, is the value of the computer depreciates $950 per year from the day of its purchase. Now that I have the slope information, I can then just pick a point and then construct my equation. In fact, I'm going to pick this point here because this point is already in this y-intercept form, or in this case, the v-intercept form. This is the v-intercept because that's where the line crosses the v-axis. So slope-intercept form, in this case, it would simply be the v value equals mx, well that's going to be negative 950 x, well there's no more x, this is the variable t here, plus the v-intercept, which is 4,000. Part C asks us, what does the slope and the v-intercept of this graph represent? The slope here is negative 950. It's actually the rate of change of the value with respect to time. So in this case, we would say the value of the computer depreciates $950 per year. Now to answer part D, we have to think of this equation as the value is a function of time t, and it's 950 negative times t plus 4,000. So because it's asking for 3 years from the day of purchase, the starting point is t equal to 0, so 3 years from that would just be t equals 3. So now the value, when it's 3 years from the day of purchase, would then be negative 950 times 3 plus 4,000, which is equal to $1,150. And this is it.